Hey guys, in this video I'm going to discuss problem 4 from this year's India National Math Olympiad. We say that a set of positive integers is cardinal if it contains its cardinality. Moreover, we call a function from the positive integers to the positive integers cardinal if any cardinal set S is mapped to a cardinal set f of s under F. Here, f of s denotes the set containing all values f of x for x elements of S. We are asked to find the possible values f of 2024 for a cardinal function f. Let us now take any positive integer n and try to find the value f of n. Therefore, we want to construct a cardinal set S such that n is an element of S. To make sure that S is cardinal, we will define it in the following way. S is equal to the set containing n, and then some numbers m2, m3, and so on up to mn. Since n is an element of S, this is a natural way to define a cardinal set if we make sure that the numbers n, m2, m3 up to mn are pairwise distinct. Since we are interested in cardinal f, we get that also f of s will be cardinal. Therefore, by definition, the cardinality of f of s is an element of f of s. But our left side is at most the size of s, which equals n. Hence, it would be nice if f of m2, f of m3, and so on would all be greater than n, because this is greater than or equal to the cardinality of f of s, which is an element of f of s. Therefore, we can conclude from this that f of n is actually the size of f of s. To pin down the value f of n, we now only need to consider the size of f of s if we are in this case. And one way to do this is to also choose our numbers such that all of these values are distinct pairwise and also distinct to f of n. As this says nothing but that the size of f of s equals exactly n. Therefore, if we can find numbers satisfying these two properties, then we can in total conclude f of n equals n. In particular, if this is possible for all values for n, then we already know that f is the identity function. Taking a look at these conditions, we see one thing, namely that f shouldn't be bounded, because here we have a condition that tells us that f of m2 up to f of mn are all quite large. On the other hand, if f is unbounded, we can indeed choose m2 up to mn in this way. Namely, we choose m2 at first such that f of m2 is greater than n and also greater than f of n and therefore distinct to it. Then we can choose m3 such that f of m3 is even greater than f of m2 and therefore also distinct to these two numbers. If f is unbounded, we can indeed continue in this way, and therefore we can take m2 up to mn such that these properties are satisfied. So it follows that f of n equals n for all positive integers n. This function f is indeed a cardinal function, and so we can write down as a first solution the value 2024 for a possible value of f of 2024. Now let us assume that f is bounded, or in other words, that there exists a t such that f of n is less than or equal to t for all positive integers n. So f only takes finitely many different values, namely 1, 2, up to t. Therefore, we can conclude that there exists a value I less than or equal to t such that this value is taken infinitely often by f. In other words, the set f inverse of I, which is defined as the set of arguments such that the function value of that point equals I, is infinite. Let us consider some number n in f inverse of I. We can construct a cardinal subset of f inverse of I in the following way. We call it S, and we want n to be an element of S, and which is a subset of f inverse of I. and we choose it in such a way that the size of S is equal to n, which is possible since f inverse of I is infinite. Therefore, f of S, which is just the set consisting of I, since all elements of that set are mapped to I under f, is cardinal. In other words, this set contains the number 1, and therefore I is equal to 1. We now almost repeat this approach, but instead of picking n from f inverse of I, we choose n equals 2024. And then we take a subset S of f inverse of 1, such that n is not an element of S, and the size of S equals n minus 1, or 2023. Therefore, the set f of S union n is also cardinal, but we can just write down this set, namely it is the set consisting of 1 and f of n, or let me just write f of 2024 here. Let's take a look at this set. The first case is that f of 2024 equals 1. Then the set is just the set consisting of the element 1, which is indeed cardinal. Moreover, we see that the function f mapping every positive integer to 1 is cardinal, so the number 1 is indeed a possible value of f of 2024. What happens when f of 2024 is not equal to 1? Then this set has two elements, and since it is cardinal, 2 must be an element of this set, but 2 doesn't equal 1, so it follows that f of 2024 is equal to 2. The function f that maps all positive integers except 2024 to 1, and that satisfies f of 2024 equals 2 is cardinal. This can be seen in the following way. If we have a cardinal set that doesn't contain 2024, its image is just the set consisting of 1, which is indeed cardinal. Otherwise, the set S can not only contain 2024, because that set is not cardinal. So a cardinal set containing 2024 consists of at least one other number, and therefore its image under f must contain 1 and f of 2024, which is 2, and this set is indeed again cardinal. In conclusion, the possible solutions or possible values for f of 2024 are 2024, 1, and 2, and therefore we are done.